Hello everyone, today's topics properties and testing of hardened concrete.
Okay, so what we have studied into first and third unit, just we will overlook on that one. So in first unit, we have studied regarding the properties of ingredient. What are the ingredients? Cements and aggregates and water. What are the different types of admixtures? Why it is useful? How the role of that admixture into improving the properties of concrete. Okay. Then in second unit, we have studied about the different properties of the concrete, like fresh properties and hardened properties. In second unit, we are focused on only the fresh properties. Now in third properties, we will go for the hardened properties. Okay, in fresh property, we have studied about the workability related. There are different types of workability measures, how we can measure through various experiments like slum cone flow table. Okay, and now here we are going for the hardened properties testing of concrete. So there are also in divided into two parts. One is the destructive and second one non-destructive testing of the hardened concrete. So what is grade of concrete? M30, M25, M30. These are the grades and nominations. So as per the recommendations of IS Indian Standard Code, at on the basis of 28 days compressive strength. Okay, that grade of concrete mentioned, like suppose M30. So that number is nothing but your 28 days compressive strength, 30 Newton per mm square, and M for the mix. So that is your grade of concrete. And nominal mix of concrete also we have studied in previous class. So what is strength? So there are two methods, destructive and non-destructive. So these are the destructive testings: compressive strength, flexure strength, tensile strength. Okay, and in non-destructive strength, we will study about the some of the methods are there, like ultrasonic pulse velocity, rebound hammer. These are nothing but the non-destructive test. Means the material which we will destruct or non-destruct from the parent element. That is nothing but the your destructive and non-destructive. So strength we will calculate by both. For existing structure, we can calculate by the rebound hammer, and for the core cutting sample, if we will take from that existing structure, we can calculate the compressive strain under the CTM in laboratory also. So that will be the destructive, because that element we have to destroy. Okay. So what is compressive strain? The ability of concrete to resist the force, that is strength. Whatever that elemental composition of concrete, that is cements and aggregate, after the complete hydration it will set 90%, 99%. Okay, so that internal material having the resistance power to the external forces, so that is the strength, compressive strength. The strength of concrete is commonly considered its most valuable property. Why? Because our structural element we can design through only the basis of compressive strength. That is the grade of concrete. Whatever the design we will make, for example, beam, design of beam, design of columns, slab, foundation. In all that design parameters, the compressive strength we will consider for the design parameter. Okay. Although in many practical cases, other characteristics such as the durability, permeability may impact the more important. For example, special some structural element like nuclear power station, some of the major dams. In such important structures, the durability along with the strength, durability parameter also considered for the design. The strength usually given as overall picture of the quality of concrete. That's why only the strength parameter we have taken for the design. By considering if the strength is good, the other parameters will also good. because strength is directly related to the structure of the hydrated cement paste. As we have seen that earlier strength and long-term strength, that is 3 days, 7 days and 28 days. And at 28 days strength, we are considering the complete hydration. Okay. Moreover, the strength of concrete is almost vital element of the structural design. As I told you that design parameter only consider for the design. In engineering practice, the strength of concrete is given age and curing by water at a prescribed temperature is assumed to be depend primarily on two factors like water cement ratio and degree of compaction. Why water cement ratio? In second unit, we have studied about that what is water cement ratio and IS 10262. That is the code related to the concrete mix design. In that one graph is given, which is shows the relation between the water cement ratio and the compressive strength. As we are going for the higher water cement ratio, that is 0.5, zero point 0.6, zero point 0.7, whatever, the strength will reduce. Whereas if you are going for the lower water cement ratio like 0.4, 0.35, 0.3, 0.28, you will get the higher strength. So that's why the water cement ratio and the degree of hydration compaction is mainly parameter for the strength. Now what are the different types of strength we will consider, like compressive strength, okay, which is related to the general design of the concrete element. Then flexure strength, tensile strength. These strengths are mainly considered for the structural element which are related to the we can say road pavement, okay, which having that element the transverse loading is maximum. So in that case, the flexure or tensile strength is considered. Then bond strength and shear strength, this strength is not in your syllabus, but I will give you just a general guideline to that one. So now we have studied about what is compressive strength. Now how we have to check that compressive strength of our concrete mix design. The IS 516/1959 has given a detailed guideline related to the how to conduct that compressive strength test. What are the specifications of that complete instrument? What are the material specifications? Everything is given into that code. The most important property of concrete is high strength, and therefore it is used to resist the compressive stresses. Whatever the external loading coming on the concrete, the internal resistance stresses are developed to resist that compression load. The strength of concrete is measured in Newton per mm square. Whatever the load comes on that cube top surface, that load divided to that cross sectional area of that uh, element. Like if it is cylinder, then that circular surface area is there, and if it is cube, then that surface square area is divided to that. So load upon area, that is your the stress. The testing of compressive strength at 28 days of curing period. In the codal provision has given that, and I have told you earlier also that we'll consider that our complete hydration at 28 days. So that strength we'll consider for the testing. The compressive strength is influenced by the number of factors. There may be chances of some compressive strength you will not get at that particular days of curing. So what are the factors are affecting to that? The addition to water cement ratio and degree of compaction. Along with this is the main parameter. as we have discussed earlier also from that graph, how the water cement ratio is affected. Along with this, the type of cement and its quality also affected to the your strength. How the type of cement, like suppose if you are going for the M33, sorry, not M33, OPC, there are three grades of cement: 33, 43, and 53. Okay, that is also related to the your compressive strength of cement. So, which type of grade or quality of cement you are taking, that is also important for your complete strength of the concrete. Then, uh, type of cement in the sense whether it is purely ordinary Portland cement or pozzolanic cement, like uh, uh, flash, if there is added, then that is pozzolanic cement. So we studied that the flash having a less reactive material, though it is a pozzolanic, but it is less reactive. Okay, so such type of concrete having a different getting strength. Only ordinary Portland cement used there having a different strength you will get. So that is the type of cement and the quality of cement is affected to the your complete strength of the concrete. Then texture of aggregate. This is also we have studied into earlier chapter that how the texture and shape of aggregate will affect to the property of the concrete. Okay, then curing parameter. Curing also is the factor affecting to your uh, compressive strain. How why we are curing required to our concrete? Can anybody tell me why we are going for the curing of concrete? Why it is needed?
The complete heat of hydration.
Exactly. For the complete heat of hydration or evaporation of internal water that we can sustain by the external curing. So if you will not get after 28 days the curing of that concrete, your evaporation of water, internal water will be more. Okay, and due to that, the early evaporation of water, the complete hydration will not be take place into that concrete. So due to that one, the less compressive strength will be occur, or minor hair cracks will be developed, shrinkage will be developed into that concrete. That's why the proper curing is needed to your concrete for getting desired strength of concrete. Temperature also affected on the compressive strength of concrete at the time of mixing of concrete or after the completion of concrete. Okay, so if there is a heat region, then in that case the evaporation of water from the free water available into the concrete mix will be more. So in such case, the whatever the desired workability, compaction will not get, and ultimately the effect on your strength of concrete. Time of hardening, it is related to the setting time of concrete. Okay, so that is also affected to the compressive strength of the concrete. So, and what is the test methodology? Okay, so there is a cubes are available for a standard sizes mold. We can say mold of where the casting of cube for the testing of concrete is recommended by the standard codal provision, like 150 cube. Okay, and second one 100 cube. So if your aggregate is more than size of 20 we have to go for the 150 cube. And if your aggregate is less than 20 size of aggregate, then we can go for the 100 cube, so that your material saving also is there. So take the batching of your ingredient as per the your mix design of concrete. Make thoroughly mix of fresh concrete, and after the taking the properties of fresh concrete, that concrete you have to place into that particular mold, whether it is 150 or 100 mm. Uh, take with proper tamping and vibration given to that mold so that the internal voids will be removed. After the complete filling of that mold, you have to keep it for 24 hours for the early setting. After 24 hours, you have to remove that complete mold. Okay, and that given in concrete cube, you have to place in a water tank for 28 days curing period. Okay, after 28 days, you have to take that concrete cube, just air dry for that removing of water and surface water, and kept it into the compression testing machine. Yeah, this figure, I don't know you are visible or not. First one figure is the UTM, sorry, CTM, compression testing machine. Then second one you are the mold where you have to cast the concrete cubes, and third one is your casted cube. So that after 28 days, that casted cube you have to place into the CTM and make a compression test. Okay. So with this you will get the 28 days compressive strength. The second test is tensile test, which is on the cylindrical. So tensile strength, actually this is the indirect tensile stress. Tensile stress in the sense of when we are going for the steel reinforcement tensile stress, that is nothing but the both hand you are pulling under the UTM. So that is the tensile strength. But on concrete, it is having a brittle material. We know that. So that test we cannot conduct on the concrete. So that's why the indirect tensile test, that is on the cylindrical mold, we can place under the CTM, and through that you can observe in this figure how the tensile stress will be developed into that cross sectional area of the cylinder. So that's why it is called as indirect tensile strain. Through this test we can calculate. So concrete has low tensile strain because it is a brittle material. It generally varies from 8 to 12% of the compressive strength. There are number of equations developed or relations between the compressive strength to flexure strength, compressive strength to tensile strength. According to that, the 8 to 12% of compressive strength will get the tensile strength of the concrete. Concrete is not normally required to resist tensile forces. Why? Because of its poor tensile property. In design, that's why we are placing a reinforcement into the our structural element, whether it is beam, column, slab, foundation, every element along with the concrete we have used their reinforcement. Means reinforcement will take the tensile stresses and concrete will take the compression stresses. This you will study into your design structure subjects also. In design of reinforced concrete, that is RCC members, it is assumed that the tensile stresses are taken up by the reinforcement and not by the concrete. As I told you, concrete will take the compressive stresses and still will take the tensile stresses. It is also called as the splitting tensile strength of concrete. Okay, this is also known as the splitting tensile strength of concrete. How this test will be carried out? Again, for this codal provision is given into the IS 516. Okay, so the cylindrical mold we have to prepare of size diameter 150 centimeter, 150 mm, and the length is 300. So the same procedure for casting of the concrete is required to the preparing such type of cylindrical mold of concrete and place it for the 28 days of under the water tank for the curing purpose. After 28 days, we have to take this cylinder of concrete and place under the CTM, as you can see in this figure, okay, horizontally, so that the vertical and compression load will be taking on that cylindrical surface, so that it will be break through horizontally, and on that load basis we can calculate the tensile strength of the concrete. Okay, and flexure strength. Flexure strength, where when the concrete is subjected to a bending action. Okay, in such cases, the your concrete is tested for the flexure strength. As I told you, the bending where will be the bending action mostly comes on the road pavements. Okay, uh, or in the airport pavement where the concrete surface pavement are used. So in such cases, the flexure strength they are considered for the design parameter. Okay, so when the concrete is subjected to bending, tensile, and compressive stresses are developed, the most common plain concrete structure subjected to a flexure is a highway pavement, runway, and so on. As I told you, the strength of concrete pavement is evaluated by means of bending test on a beam specimen. So, how to conduct this test? Flexure test, like for compression test, we are using 150 cube or 100 size of cube. Here, for flexure test, we are going for the beam test of a small size, 100 by 100 by 500 length. Okay, so you can see in this figure also such type of beam we have to cast it, and after 20 days again we are used for the under the CTM. But for flexure test, the assembly is different for the testing, because that beam is supported by simply supported, and the the vertical loading done through the single point load or double point load in both way. So similar process is there. As per your mixed design of concrete, you have to prepare fresh concrete, place into such mold, 100 by 100 by 500 mold, uh, place it for 24 hours. After 24 hours, you have to remove that mold, and the prepared concrete beam, you have to place it for the water curing for 28 days. After 28 days, you have to take that concrete beam and place in the compression testing machine for the flexure test. Okay, from calculating the load, you will get the flexure strength of concrete. Clear? So this is nothing but your compression test, flexure test, and tensile test. Whereas the bonding strength or pull out test, this test is there. So what is bonding strength? The measure of the adhesion between the concrete and steel. That is nothing but your bonding strength or pull out test. That this test will take the assurance of the bonding between the steel and the concrete. When steel is embedded into the concrete, it is called as the bond strength or pull out test. It is more for vertical bars than horizontal bars, because it is subjected to a tensile. The bond strength can be increased by using the deform bar instead of the plain bar. You maybe have seen that the reinforcement provided into the any construction site, the torque bar is available. Means on the surface of that reinforcement, there is a curvatures are provided. Okay, slightly. So that is required for the bonding between the concrete or ingredients of the internal concrete. Earlier construction, the plain reinforcement are provided. So after this long research, they were found that the bonding between the plain reinforcement and concrete is not that much high. So if we are use the torque bar instead of that plain bar, that will be the beneficial for our gaining the bonding and ultimately the increase the strength of the concrete. Generally, hooks are provided in the steel reinforcement to increase the strength. Hooks in the sense at the end of the reinforcement okay, element in any particular uh, element like column or beam or slab, we are providing the hook. Okay, 9D, 3, 12D, that you may be read into or studied into the estimation subject or any design subject. So that hook nothing used for the purpose of the bonding only. So from this test, we get the bonding strength between the reinforcement and concrete. Okay, student. So these are all about the destructive method. In next class, we will